Alright, the first thing we're going to do is use this CAD program and set up a little schematic diagram here. We'll go up to the upper left corner here. You can see I'm representing the solar panels, the PV, as a battery. And what I decided to do is to put in a single pole double throw switch, actually with a center off position, that allow me to individually select whether I want the PV current to go to the grid tie inverter that's assigned to it, or to a common bus bar that will tie all of these panels in parallel, driving the charge controller. So that's the basic idea on the left here. Is it gives me I can scale this down. I can add probably as many as I want, really, but I just have the drawing set up for 6. So then we assume we kind of understand that, you know, the output of the grid tie inverters are going to feed those meters that I showed in the video part, and feeding the wall, so I don't need to represent that on the schematic. But if I go over here and look at the rest of this charge controller section, I'll come off the bus bar here, and I decide I'm going to go into a ammeter so I can really kind of in real time see what the amps are coming in off the solar panels, because they change quite a bit. And if I add up the PV amps that I currently are getting and then have some room for growth, I decide to set that up for a 50 amp meter. Going through the ammeter, feeding down into the charge controller is pretty straightforward. Out of the charge controller, its job is primarily to feed the battery bank, and what you need to have off of your battery bank is you need a fuse to the charge controller in case there's a short in the charge controller, that there's just something to stop the avalanche of power that's going to get dumped. So I set that up for 60 amps, which is higher than the 50 amps that the charge controller is rated at, so it won't blow in a normal operation. And then on the other side, here's my 2 regular DC to AC inverters that they're each going to be rated about 100 amps of input. So you need to have about a 50% margin above that on your fuse. So I have 150 amp slow blow fuses in front of both of those. And you can see my battery banks are made up of these 6-volt Trojans, so 2 of those in series gives 12 volts, and then another string of that in parallel, so that makes up my 12-volt battery bank with 450 amp hours. Now the way the Trimetric is designed, it's designed to utilize a sensing shunt off of the negative side of the battery bank prior to getting to ground. So that's how I depicted that in this picture here. So everything's reasonably straightforward. There's nothing too difficult about that. But the kind of the next key thing is to look at the physical view and see what's a smart way to get this thing drawn up on a board. Now I don't want to have, like a lot of people do, just one big piece of plywood and everything kind of hanging off it, strung together, where it's a little bit easy to get tampered with. And so I decided I'm going to try to have a nice clean setup. So I'm going to go with a gray box in the center here, like a utility type of box, where I can have my PV coming in. So I'll have like 6 pairs of wires coming in from my PV panels coming in, and each one will feed one of these switches. And these are the switches that will be up will mean feed the power to the charge controller, down would be feed it to the grid, and then there'll be a center off position for each of those, saying it'll basically disconnect the PV from either. And that'll feed through the then there'll be an ammeter on the front of the box, and that'll be about it. Coming out of the gray box will be the wires that would go from the switches to the grid tied inverters like they do now. So there'll be 6 pairs of those minimum. I'll also have a major large piece of wire, which would be at least 4 average wire gauge, to take that 60 amps of current over to the charge controller. Coming back out of the charge controller, as you notice up in our prior diagram up here, we need to pick up this fuse from the charge controller. So down in the box, we want to make sure that so we come back from the charge controller, we're going to have that fuse right inside of this gray box, and then the coming out of there, we need to go from those fuses to the down to the battery bank. So that's what these wires here are for, coming down to the battery back out, picking up the shunt that was shown here. So I'm going to have that in the gray box as well, and that will then get wired to the Trimetrix, which comes in with just a two twisted pair, low voltage cabling to the Trimetric. And then in order to pick up these two fuses here for the inverters, we'll take, since we know we got the top positive part of the battery bank into the gray box here, inside of here we'll have each of those two fuses with each individual output going to each of the two inverters. So it should be pretty simple. I should just have the Trimetrix, the gray box, the charge controller, a minimum amount of wires externally, two big wires down to the battery bank, two big wire pairs out to each of the inverters, and everything should look nice and tidy. So I've ordered a bunch of parts, and when those come in, we'll get the rest of it put together, but I thought I'd at least show you part of the planning process. And if you have any questions, let me know. Talk to you later.